A container is constructed from a hollow cylindrical shell and a hollow cone which are joined along their circumferences. The cylindrical shell has radius 0.2 meters and the cone has a semi-vertical angle 30 degrees. Two identical small spheres P and Q move independently in horizontal circles on the smooth inner surface of the container. See figure 1. Each sphere has mass 0.3 kilograms. P moves in a circle of radius 0.12 meters and is in contact with only the conical part of the container. Calculate the angular speed of P. Here are figure. What forces we have got? Here is the normal force, it's perpendicular to the surface, and gravitational force. We break down this force. We have a horizontal and a vertical component. Here is a right triangle. This is 30 degrees, so this is 60 degrees. And 90 minus 60, this is 30 degrees too. As this component is adjacent of this angle, so it's n times cosine 30 degrees, and these are the same, and it's opposite of this angle, so it's n times sine of 30 degrees. MP is equal to 0.3 kilograms and this radius 0.12 meters. These two forces are the same. N times sinus 30 degrees is equal to m times g. So n is equal to 5.88 newtons. At uniform circular motion, acceleration is equal to velocity squared over radius, or angular speed squared times radius. And we can apply Newton's law. We have one force, n times cosine 30 degrees, this force, and it's equal m times a, which is angular speed squared times r. We divide m, r and square root, so angular speed is equal to this expression. After substitution and calculation, we get that angular speed is equal to 11.9 radians over second. Q moves with speed 2.1 meters per second and is in contact with both the cylindrical and conical surfaces of the container. See figure 2. Calculate the magnitude of the force which the cylindrical shell exerts on the sphere. Here are data. What forces act to the sphere? Here is the normal force of conical surface, and here is the cylindrical force. We have to find out this. We break down this force. We have a horizontal and a vertical force, like before. This is NCO times cosine 30 degrees, and this component is this, and here is the gravitational force. As before, NCO times sine 30 degrees is equal to m times g, so NCO is equal to 5.88 newtons. At uniform circular motion, this is the acceleration. Newton's law, there are two forces, this and this is equal to m times v squared over r. We express this normal force, subtract this, and after substitution we get that the cylindrical force is 1.52 newtons. Calculate the difference between the mechanical energy of P and of Q. Now mechanical energy is equal to kinetic energy plus potential energy. This is kinetic energy, potential energy. This is the zero, here zero, the potential energy, here zero. Here is P, Q, and first we calculate the height of P and Q. Here is a right triangle. We can apply tangent. Tangent 30 degrees is equal to 0.12 over HP. So HP is equal to 0.208, and the same HQ 0.346. We should calculate the velocity of P. It's angular speed times radius. It is here. We know velocity of Q, so difference between the two mechanical energy, kinetic energy of P plus potential energy of P minus kinetic energy plus potential energy of Q. We substitute and calculate, so we get that our solution is minus 0.761 joules.